Hi everybody. The next section I want to look at is section 1.4 on radical equations and equations that are quadratic in form and other factorable equations. Just to remind you quickly of what a radical equation is. A radical equation is just something, it's an equation with a square root in it. So you might have something, for example, like the square root of, say, x minus 2 equals 3. And you might remember the basic procedure for solving an equation of this type essentially is to just square both sides. So if I were to square the left-hand side, for example, if I square something that's squared, or square-rooted rather, I get the square root and the square will cancel. So this side will just be x minus 2, and here I'll get 9. Then the idea then is to just add 2 to both sides, and you'll get x is equal to 11. And again, you can check that by plugging that back into the original equation, and you'll see that it will work out, because you'll get the square root of 11 minus 2, which is 9, and the square root of 9 is 3. So that's the basic idea. Now, one thing you have to be careful about with these sorts of equations is just like rational equations, equations with fractions, you really do need to check your answer when you're done. As a quick example, let me give you an example of an equation that won't have a solution, kind of like we did when we were dealing with rational equations. So let's say, for example, you have the square root of, say, x minus 3 plus 7 equals 5. So the idea, again, is when you're solving a radical equation, the first step basically is to try to get the radical alone. Try and get the thing with the square root or cube root by itself and everything else on the other side. So now the 7 is not contained in the square root, so we want to move that over. And you'll get x minus 3 is equal to negative 2. So now if you square both sides, like the last example, you'll just get x minus 3 equals 4, right? Because negative 2 times negative 2 is a positive 4. And then if you solve that equation for x, you may think, well, I've got the answer, which is 7, just by adding 3 to both sides. But if you check that answer, it doesn't quite work, right? Because you'll get the square root of 7 minus 3, which is 4. The square root of 4 is 2, and 2 plus 7 does not equal 5. So one thing you have to be careful about with these sorts of equations is you do have to check your answer like rational equations. You might see here in this step that something's wrong because there's no way you can take the principal square root of a number and get a negative. So again, the answer for this is actually no solution. So again, when you're doing the homework on computer and stuff, it should it should give you that option if that is the case. But on the final exam, again, which will be written on paper, I will expect you to actually write the words no solution. So keep that in mind. Now, these sorts of equations can be substantially more complicated. They won't all turn out to be linear once you've squared both sides like we just did. In fact, there may be certain types of these equations where you may have to square or cube both sides more than once. An example would be something like where you have the square root of, say, 2x plus 3 minus the square root of x plus 2 is equal to 2. Now, the trouble with this one is, again, these two radicals cannot be combined together. They cannot be put underneath one square root because you're adding and subtracting here. Now, if you were multiplying, you could put them together, but because they're adding and subtracting here, you can't quite do that. One thing I want to warn you about also is, if you square this side, remember this is like a minus b squared, and if you have to take a minus b squared, remember that's equal to a squared minus 2ab plus b squared. So you can't just simply square that and square that. So the way to tackle these problems that have two separate radicals in here is to move one of the radicals to the other side. So in this particular case, I'm just going to take the negative square root of x plus 2 and move it to the right-hand side. But it doesn't really matter what side you move things to. So if I do that, I'll get 2 plus the square root of x plus 2. Okay, now again, just square both sides to try and get rid of the square root. So over here, if you square this side, it will get rid of the square root, but on the right-hand side, you have to be a little bit more careful. So here you have the square root of something squared. That should just give you 2x plus 3 here. Now on the right-hand side, you have to be careful because remember, that's really 2 plus the square root of x plus 2 times another 2 plus the square root of x plus 2. And again, you have to FOIL that out. So again, you can't simply apply the square to each thing separately. It's not just going to be 2 squared plus the square root of x plus 2 squared. So you do need to FOIL that out. So over here you'll get 2x plus 3. Then FOILing this out, you'll get 2 times 2, which is 4. And then you'll get 2 times the square root of x plus 2, but then you'll get another 2 times the square root of x plus 2 from here. So you'll have 2 of those, or in other words, or you'll have 2 of those together. So you'll get 4 times the square root of x plus 2. And then lastly, when you take the square root of 2 times, or square root of x plus 2 times the square root of x plus 2, you take the square root of something times itself, that just gives you x plus 2 back. Now the only trouble is now you've still got another radical in here, so well, what do? Well, just like the previous example, if you have something with a radical in it, try to get the thing with the radical by itself and everything that's not inside the radical on the other side. So moving everything that's not inside or in the term with the radical over to the right-hand side, so subtracting an x from both sides will give me an x on the left, and then I've got 4 plus 2, which is 6. If I subtract that from the other side, I'll get a minus 3, right? Because 3 minus 6 is minus 3. And then over here, I'll get 4 times the square root of x plus 2. Okay, now you can divide both sides by 4 at this point if you want. But what you can basically do at this point is square both sides again. Now, again, because you're multiplying the 4 times the square root of x plus 2, you can actually apply the square to each thing separately, right? But on the left-hand side, again, you have to FOIL again, right? Because it's not just going to be x squared minus 9, right? It'll be x squared minus 6x plus 9, because you're taking x minus 3 times x minus 3. So over here, you'll get x squared minus 6x plus 9. And then on the right-hand side, 4 squared is 16. And then you're taking that times the square root of x plus 2 squared, which is just x plus 2. So you'll have 16 times x, which is 16x, and then 16 times 2, which will be 32. Okay, now again, this is turning out to be a quadratic equation because you've got an x squared in there. So if you move all that stuff over to the right-hand side, or to the left-hand side rather, you'll get x squared. Let's see, negative 6 minus 16 is going to be a minus 22x, and then 9 minus 32, that'll give you a minus 23, and that'll equal 0. So just going back up to the top, because I know we're running out of room here, you'll have x squared minus 22x minus 23 equals 0. Okay. Now that equation, either you can plug into the quadratic formula, or if it's factorable, you can factor it. In this case, I think you'll notice that it's factorable. It factors into x minus 23 and x plus 1 equals 0. So you'll get 2 solutions. You'll get 23 and negative 1 as solutions. Again, both of those which you have to check because one may be a solution and the other one may not. Now, I think in this particular case, the x equals 23 solution does work, but the x equals minus 1 doesn't work. So make sure that, if you're typing that into the computer as an answer, you just type in the 23 and not the negative 1. So just something to be aware of there. So just be aware that quadratic equations can show up in these sorts of radical equations. One other thing I want to talk about is equations that are quadratic in form. So, in other words, equations that aren't really quite quadratic, but where you can use the techniques from quadratic equations to solve them. An example would be something like, let's say that you've got, say, for example, x plus 2 squared plus 11 times x plus 2 minus 12 equals 0. So if you look at that, I guess you could FOIL everything out here. But one thing that might be easier to do is just do some sort of substitution, like replace x plus 2 with some other variable like u, and then you'll get u squared plus 11 times u minus 12 equals 0. Now you might notice that that one is factorable. That will factor into u plus 12 and u minus 1. So you'll get u is equal to minus 12 and u is equal to 1. Now keep in mind, though, that you're solving for x, not u, so if u is equal to x plus 2, that would mean that x itself is actually equal to minus 9 if I add 2 to both answers, or sorry, I guess I want to subtract 2 rather. If I subtract 2, I'll get minus 14, and here if I subtract 2 from that, I'll get x is equal to minus 1. Now again, that's not a radical equation, so you don't have to check your answers for that. But you know, it's always a good idea to check your answer just to be on the safe side. Maybe just to talk about another type of equation you might run across. You know, it's possible to talk about solving higher degree equations by factoring. Let's say, for example, you have something where you've got, say, for example, x cubed minus x squared minus 4x plus 4 equals 0. Now we'll talk about some of these equations later on. One thing you might be wondering about is there something like the quadratic formula for equations of degree 3? If there is, you could possibly use it. But the basic idea is all we really know in terms of solving equations of degree that are higher than 2 is to factor. So try to figure out some way of factoring this. Maybe you can pull out a common factor, like maybe there's an x you can pull out of all 4 terms. Now in this case, you'll notice that there isn't an x in the last term, so you can't quite do that. But just kind of going back to some of the more obscure factoring techniques that you might have forgotten. If you remember, one of the techniques is to factor by grouping. So although there's no common factor you can pull out of all 4 terms, maybe you can factor the first 2 terms and then sort of group the last 2 terms together and factor those. And by looking at that, maybe there's a common factor you can pull out. So the idea, again, is if you look at the first 2 terms, I can pull out an x squared, leaving you with x minus 1. Here I can pull out a negative 4 out of the last 2 terms, leaving you with x minus 1 also. So now I've got 2 terms, both of which contain x minus 1, so I can factor that x minus 1 out front, leaving me with x squared minus 4 equals 0. Now if you look at the x squared minus 4, that's a difference of squares. Right? That's going to be x minus 2 times x plus 2, right? Because remember that a squared minus b squared is equal to a minus b times a plus b. So in this case, I'll actually get 3 solutions. I'll get x is equal to 1, x is equal to 2, and x is equal to negative 2. And again, like I said before, the degree of the equation has some bearing on the number of solutions you'll have. So again, that's why you have 3 different solutions in this case. Right? Remember, you could have that many solutions or fewer, so there's no guarantee you're going to have exactly 3. You could have less, but in this case, you do have exactly 3. So just be aware there might be some equations in this section that are not quite quadratic, but you can kind of use the techniques for solving quadratic equations to solve them. If you get stuck on those, some of those can be kind of difficult. Make sure you ask me about that. Right, well, I think that's it for that section. So, like I said, if you guys have questions, make sure you let me know. All right? Good luck.